Hey everybody, back with another Jacklick's arcade repair video. If this Jacklick can repair these things, so can you. This is the next one in the GORF series. I'm working on these GORF sets, and some next up is these pattern boards. So I have two loose pattern boards, and I have two untested pattern boards that are part of a cage set. And I've never repaired one of these before, and I know some of them don't work. So let's go ahead and set up the bench and start testing these things and figuring out what's wrong with these. Alright, first board up. I checked for previous work, and U40 and U33 over here have both been replaced previously. But other than that, the board looked good. Did quick inspection. Check this cap. It looks, or at least it's not shorted, is what I would say. So let's go ahead and power it on. Oh yeah, and I moved my game board to the last slot just because I'll be moving stuff in and out of this first slot to make it easier there. And we got problems. Yeah, that looks just red lines, but it looks like the game's running, obviously. Maybe I should hook up some sound. Yeah, I can tell the game's running because you can see you could probably see the bullets and stuff. You can just see the explosion there. Yeah, wacky. Alright, so pattern board failure right from the get-go. Let me research how I'm going to fix this. Alright, hopefully you guys can see this and I can hold my hand steady. The first thing I did is started looking at Midway's card rack system part 1, and it kind of goes over if you have the test board set, which I don't have, but I think Sean and Sam, I'll link, they've used the boards and stuff like that. It probably will be helpful, or would be helpful for the pattern board test. But what I figured I would do is it does break it down into you know, what are fatal errors versus what are some other type, like data bus errors and stuff like that. So I'm just guessing, don't know, but because of that static image, it seems like it might be a fatal error because something is stuck, you know what I mean? It's not moving anything around the screen, for example, in the background. So I figured I'd take a look at these fatal errors in the chip locations first. And you can see here at U21, it says it's a 74174, but right now there's a 14174, which is a CMOS chip, I believe. So it's a hex. It's a quad or hex D type flip-flop something another, whatever. And that's one I wanted to look at, as well as, you know, some of the other TTLs that I can look at in my logic comparator, like the 74LS161, the LS04, the LS000. I can look at these all with my logic comparator, the 367. I don't have a lot of the CMOS chips, so I don't know if I look at it with an equivalent TTL if it would make a lot of sense. But that's what I'm going to do first, is just start probing around and using my logic comparator and see if I can see anything interesting. Alright, so I started looking at the chips, you know, some of the TTL with my logic comparator there, and I just put green dots by the ones that were testing fine. So this LS00 at U12, U6, U43, those at least tested, looked okay on the logic comparator. It doesn't necessarily mean anything. And then I was coming to these LS257s at U8, U17, U26, and U35. There's 4 LS257s there, and all of them have the outputs reading bad. As you can, let me see if I can get it on there good. See that? But that doesn't necessarily mean anything. You got to remember, on a logic comparator, if there's other stuff on the data outputs, right, it could be messing up the readings. And in this case, those are, let me see here, where's U17, U8, this is in the linear counter section, basically, and there's basically like horizontal and vertical, and I think the top part is the vertical part, and then over here is the area counters or something, might be the horizontal, I'm not sure, but I have to read through this theory of operation again. But anyway, most of these are tied to the address bus, and so there's other stuff going on the address bus that's likely messing up my readings on U17, U18. You can see there it's, you know, tied to address 12, address 5, etc., etc. So anyway, that didn't really interest me too much, the fact that the outputs were bad. But let me show you something else that was interesting. So you can use this the HP Logic comparator here with the universal card. You can actually use it as a like an IC clip and just monitor all the pins with a single, you know, clip basically. And you can see here pins 4, 7, 9, and 12 are the outputs, and they have activity on it. If I looked at these on a scope, there would be a lot of activity. It's almost completely solid because it's so fast probably. But the inputs, there's nothing. 2 and 3 is an input, 5 and 6 is an input, 8 is ground, 10 and 11 is an input, 13 and 14 is an input, and there's just no activity at all. And that was kind of interesting to me. So this is showing you as an example that the outputs were reading bad because there's address bus activity, which is messing up what the outputs are seeing there, and there's nothing on the inputs. So there should have been nothing on the outputs, but obviously it's tied to the address bus. So let's look at what is inputting into that and see if we can trace it back, because that might give us... Alright, so the inputs into U17, 3, 6, 10, and 9, that's half of the inputs, and the other half is coming from, instead of the linear counter, it's coming from the area counters section. But you have 3, 6, 10, and 9 are some inputs into U17, and that comes from U16. And here's U17, and it comes from U18. So basically U18 and U16 both feed U17. So let's take a look at that. I should have taken out that chip probably, but it doesn't make any difference. Same reading. It's basically just pushing all, you have to move all of your output lines to the output stage, and it's basically just pumping them straight through, and this IC clip switch here turns it into this I forget what they call this whenever you, an IC clip activity reader, I don't know. Alright, so what are we checking? We're into U17 is U18 and U16, and both of those are right next to each other, so they're right here, U16, and I can just, even though it's CMOS, I should be able just to, you know, clip onto it. There we go. Well, look at, kind of changes the color there. Oh, there we go. Alright, cool. Yeah, it's still running. And now I have nothing on pin 2, 6, 11, and 14. Now I need to go look to see that, but I do have activity on the other line. So let me look at my schematic and see what those are. Yeah, okay, so according to the schematic, 2, 6, 11, and 14 are the outputs, and we see that those are definitely not working correctly. And pin 1 is some type of enable, I think, in pin 9. So, and there's activity on the input. So why isn't it outputting something? That's kind of weird. I don't know. I'm gonna keep going backwards, but I think I'm gonna like probe this with the scope and just see, because this seems interesting to me. Like, this data is coming in, but this chip is not acting on that and passing it along to the linear 257s, which are, what the hell is a 257? The multiplexers, which is the 257. So it's not passing this on to the next chip. Alright, I'm just tracing this back. So like these counters, these 4516 up down counters here, you know, kind of feed each other. Like their carry out goes into the carry in of another counter. So they're kind of like all tied together. Like here's the carry in over here, pin 5, that comes from U25's carry out. U25's carry out, you know, carry in comes from U34. U34's carry out is determined by U3's output. And so I'm just kind of tracing this back because all the clocks look fine, like pin 15 on all these counters look fine. And I'm just thinking and I think this is always tied high. No, pin 10, where's pin 10 at, is always high, which is the up down, whether it's counting up or down, I guess. Pin 10, that's tied high. So you really have pin 1. Pin 9 is the reset line, which that's driven by the CPU, so I think that just like resets everything at once. I looked at that. It wasn't quite all the way up to 5 volts, but it was high. I mean, it was like around 4 or something like that. Yeah, so I mean, it's got to be, I doubt all of these are wrong or bad, so it's got to be like the carry in not being right, coming from U3 maybe, or one of these failing, you know, to carry out, because once one of them fails, then I think all of them are kind of screwed, or at least further down in the chain. So I'm going to look at pin 7 and pin 5 of a working board here. Pin 1, maybe as well as pin 1, 7, and 5. Alright, I have my working board up. Let's look at pin 1, just from a logic probe standpoint. See if I can get in here. Alright, so pin 1, there's my working board. It's looking good. It's toggling like crazy. 2, 3, 4, 5. Depending on what's going on the screen really determines like how active that thing is. Just gonna watch it for a little bit. Now it's really busy when there's stuff being drawn on the screen, right? And then pin 7. Yeah, it's busy. 8, 9. It's just low. Alright, let me put my, I guess I could look at it with the scope too, just to kind of show that's pin 7. And that's what's going on the screen, so it's kind of determined a little bit by that. Pin 5. You can see it's kind of flashing, pulsing at different intervals there. Alright, let me put my non-working board and look at U34. Alright, so I was just hunting and going in circles, really looking at these counters, because everything was like feeding into each other and the outputs go into other stuff. And then I was like down here in the feedback section, or the area stuff, and looking at inputs of U36 and U27. It's just, it was good. I was losing my mind. So I stopped and came back and watched Sean's video on Classic Arcade Repair, and he was looking at a counter and his reset line was always low, and even mine wasn't going all the way to 5 volts, so it did look like something was weird with that reset line on pin 9 of U34, and it looks the same on all of them because they're all using the same reset. And that means that's probably why I'm not getting anything on the output, is the reset line is always high, therefore the counts always reset, and we're not counting. So if I was like, well, why is that? I figured that was the reset line from the CPU, but the reset line from the CPU is where are you at? Right here. This reset active low. And if I come down here on the pattern board, reset active low signal from the CPU board comes into U14. Pin 10 gets inverted to pin 9 and creates the reset active high signal for all of these counters. So those counters should always be low on the reset line. So let me go back to the board and take a look at something. There's my board. There's my oscilloscope. And here is U14. Pin 10 is high. That's reset active low coming from the CPU board. And that, if I can get on there, that is pin 9. And you can see it's like about a half a volt, you know, lower, maybe 1 volt lower. Well, actually, I should say that's 5.24 volts, it says. And pin 3.8 volts is what it says on. Hopefully you guys can see that. So that should actually be low. And if I ground it, which I think is safe, grounding an output, you don't want to pull outputs high, I don't think, but if I should be able to ground it safely. But watch, if I ground it, you start to see characters move. We still have our red lines. Oh, look, that completely cleared it up. See? What just happened? Is it stuck? Alright, let me reboot. Maybe it was just a stuck pin. Alright, there we go. So we have our little GORF thing, and if I ground it, you'll see our counters are probably starting to go. See, look, it's starting to scroll now. Starting to clear up. Boom. That's probably our whole issue. I just fixed it just by grounding that reset line. That was the only thing that's wrong. Awesome. I guess we found our problem. That U14, unground it, we're completely jacked up. Yeah, see, I'm just touching ground and untouching ground. It's just basically stopping the counters from working. That one chip. Alright, it looks jacked up now, but if I power off, ground this pin from the start, now let's power up. Boom. Looks fine. Alright, so our culprit's U14. I have to find out, that's some type of CMOS chip of U14 is a 14572. So I don't know what that is. I'm sure I don't have any, so, but that looks like that's our problem. And watching one of Sean's videos, I had watched it before, but watching it back actually gave me the clue, because he was talking about the same chip, the same counter chips, and pin 9 needed to be low. I put in my working board just to verify, and yep, sure enough, on my working board, pin 9, the reset line was low. Traced it back, U14 seems to be the fix right there. Well, before I did, just went and replaced it, I cut pin 9 on U14, and you can see that's pin 10, and pin 9 is, wow, why is it so blurry, is low, and it is pulled high on the part that I clipped. So that means that something on that reset line is pulling the thing high, and you can see because it's reading 5.16 volts, and when I had it connected, it was like U14 was trying to bring it low, but it just wasn't able to, because something on that line is shorted to 5 volts or something. But I can overpower it by grounding it. But we have a shorted chip somewhere on that reset line, and that means some other counter. Oh my god. So I have a short, so I need to find the short, right? I guess. Oh man. Alright, so this could be interesting because I haven't used this LeakSeeker very often, and it's really, I think, supposed to be hooked up to ground. But what I figured I was just experimenting with this, is, and this LeakSeeker is to find shorts basically, is I think we have the reset line is shorted somewhat to 5 volts. You know, it's not exactly 5 volts. If I put it on the ohm meter, it's like 3,000 ohms or something like that. And literally, I don't think this thing is designed to do this. But what I did is we'll hit our reset and we'll come to our reset line that we cut. And it's going to calibrate, right? And then we can check the other reset lines and see if we're getting further or closer. See, so it recalibrated there. And if we get closer to the short, so that's further. And I might have to recalibrate. Let's see here. We'll recalibrate to this one. Alright. That's further away. Further away. Hopefully you guys can see this. Let me come back here. Far away. Closer. Whoops. Damn it. I touched the wrong pin. If you touch the wrong pin, you gotta hit reset. Alright. See that one? That one's almost the highest one. And I already know what chips these are. We have all these counters. Counter, 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 counter. And then there's 4 counters here. And I think that's all of them that are tied to that reset. So we'll calibrate here. Alright, are we closer here? We are closer. Are we closer here? Further. Further away. So this one seems like could be our problem. That's further. Far. Calibrate again. See, that's far. Far. Real far. I don't know. I'm thinking U27 might be our problem. Let me, I guess I'll just cut that chip and then see. I mean, cut that chip leg. This is kind of interesting. I have no idea if this is going to work. That didn't work. I'm still high on the reset line on my counters there. So, but it does float yet low. So when you cut the pin, it floats low, and so if you come to one of the outputs, which is like pin 2, it starts counting. Obviously, you can see that. That's like pin 2, 3, 4, 5, 6. See, when the pin 9 the reset's low, it starts counting again. So I guess I should start with probably U34 maybe, and cut that one. I don't know if I'm doing the right thing by cutting these. I mean, it's got to be one of these chips is bad, because I don't think U14 is bad, because it is low. It's doing the right thing basically, or at least it seems like it. Now by cutting it, everything's high, and we know that it should probably float low. So If it's not a chip, then something's bridged or something. Now these two counters here at U40 and U33 were replaced, so, and I did look at them. They don't seem like there was any solder bridges or anything like that. 4516. Yeah, 4516. So I mean, they're the same. These are all 4516 counters. Oh boy. All right, let me see. I might have to replace a lot of these counters or bridge up a bunch of pins. Okay, I think I found the problem. You can see, doesn't look good, but U33, I cut that pin 9 right there, and I dropped. Why is that so blurry? There we go. That's low on the, but on the actual chip it's high. So that disconnecting that pin from that reset line, I guess is what you could call it, drop the reset line to low. And so I just need to reconnect U14 and some other pin 9s, put some solder on those, and then replace U33, and I think that's our problem. Alright, while we're waiting for this chip, this 4516, I think is what it is. Yeah, 4516. While we're waiting for that chip to come in, figure out how to test this board, and I think we'll call this board number 2, and it looks like it's working fine. No issues there. We'll just let it scroll through. Oh, everything looks pretty good there. Alright, so that one is working, it looks like, and I know I have this one that doesn't work, and one more I'll show you in a second. Alright, board number 3, blank screen. Absolutely nothing was happening here. Now that I know to check at least a few pins, let's come to pin 9 of this thing. Okay. Oh, it's actually causing a reset. Look, pin 9 is the reset line, reset high line I should say, and it is resetting. So something on this board is causing the entire board to reset. Remember when I cranked up the contrast? Yeah, see, we can see the star field coming on and then it resets. Because I'm just cranking up the contrast, because you wouldn't see that normally. But this board is causing the entire board set to reset. So let me think about what I want to do. But this is probably a good thing, because it's probably some catastrophic failure here. Just reading and guessing a little bit here. This section of the theory of operation here says when the bus acknowledge goes low, I don't really understand what's going on. Basically, it allows the pattern board to take control of the bus and put data probably on the data bus, etc. But it says here that the master clock generator U5 starts counting when that happens. So I just was like, that sounds kind of important. I don't know if it sounds like some timing issue, like data. It's resetting because probably things are on the data bus when they shouldn't be, or things aren't being, the addressing isn't happening. I would assume the address decoding to the pattern board isn't a problem as much as junk going on the data bus causing the CPU to recycle. That's just my guess. But anyway, I'm going to check U5 is a 161. I have my logic comparator hooked up to it, and we are getting Looks like bad data on pins 13 and 14. I never trust the logic comparator on counters and stuff, but that's kind of my best guess right now. And I might probe around a little bit. Actually, I already did. Pins 13. I mean, I see activity level there, right? It's obviously resetting. That's 14, actually. That's 13. So why is it just plain wrong? Nothing on pin 15, which should be the ripple carryout, I think. That's interesting. Pin 1. That's 2. Yeah, I don't know. That's pin 9. I doubt that's bad, but I might replace it because I'm kind of don't know where else to look yet. One of the things it mentions is there's the address decoding coming in goes into like U1 or 2 and stuff. I might probe those just to check the addressing. Let me see here. U1 pin 13 is right there, and it's not doing. It's just toggling, I guess. And that should be the decoding. I mean, oh no, that's pin 2, sorry. There's pin 13. Just, if I hold it on there, right? Looks like it's just high. Yeah, the inputs, I don't know what's going on there. Alright, I went ahead and replaced the 161 at U5, and it did test bad in my tester. We're looking good. That was the issue. It was resetting, probably because the timing was jacked up, and this U5 is critical. Now, I wish I would have known exactly what was wrong with it, but logic comparator kind of hinted at it. Looks like we're good. Second board almost fixed. I still need another chip for the other one. Let me see how long this video is. Alright, board number 4. This is the last board, and this symptom is definitely going to be a lot harder to fix. Here we go, powering on. And if you can see it, how it's bouncy, or it's like jerky or something when the GORF comes out. Now that part looks fine. You can't really tell. It's only with motion objects, I think. We have to wait here a little bit. Oh, and the text is a little scrunched up at the top there. And then look how jerky the Galaxians are. Yeah, same with that. It's only certain objects that are like really jerky. Things moving down. So this one's definitely a weird one, and I have no idea. I'm gonna have to, this might be where the test card would come in handy, because it's definitely not a complete failure. It's something that's just off a little bit or something, like a failing chip somehow. Alright, I'm doing some serious experimenting, learning, and stuff like that. I can't really tell you, I'm not going to be able to articulate, you know, what I think might be going on or anything like that, but this is a key, you know, thing that I want to look at, because game over and mission, those are the only, you know, character graphics that are scrunched and looking weird. The scrolling looks fine, and honestly I don't even know if that scrolling is using a bunch of the pattern board to move objects around on the screen. I'm not sure. It's kind of interesting to me. But I'm reading the theory of operations. Yeah, see, this is supposed to be up further. And like here, look, these things are in the wrong location. So when you look at the theory of operations, besides the jerkiness that maybe, I mean, we might have two different issues going on, I don't know, but you know, you have the schematic that talks about like area and load and all this other stuff, and then the theory of operations mentions like the kind of like the starting point of the drawing, or really the pattern board is there to move data on the screen or from memory to the screen or something, from like RAM or ROM or something like that, faster. So this whole board was here so it could, I guess, probably move data, you know, around faster, basically. And there's this source section, which I assume is like the starting point, and I think they call that the linear section, but they said that's where like the source is. I don't know, I'm trying to interpret what the heck they mean by it, but I'm interpreting it to mean like that's kind of where the start of the drawing may be happening. And then you have the area, which is the destination, and then you basically have this width and height counters that are going on, and you know, some timers are decrementing in this feedback loop here, and it's basically, I think, drawing horizontal. So it's like starting, and then it draws it, and it's the next line, and it's like source, destination, and the counters are kind of decrementing and changing, so it's drawing the whole horizontal line, and it does that for every single horizontal line or something like that. Again, I'm kind of just talking you through where my brain is at, basically. But the other thing I started doing is, beyond looking at, you know, schematics and stuff, is I actually hooked up all 4 channels of my Rigol here, and this is the first time I've actually messed with all 4 channels like this. And I'm looking at I'm looking at U39. I haven't found anything interesting yet. So U39, which is a CMOS 14175. It is a, I assume it is a hex quadruple D-type flip-flop. So I'm looking at a 74S or LS175, but I think it's the same pinout as I'm pretty sure. It looks to be the same anyway, as the CMOS version, which is 14175. Excuse me. So anyway, pin 1, or the channel 1 is, I believe, my clock. Yeah, that's my clock. And so this is a positive edge triggered flip-flop, and I'm not a logic expert. I'm just kind of like doing this to experiment. And then the blue line is my data, and then I have my output Q, and then my not Q, I think, right? Yeah. So basically, when the clock goes high, that triggers the outputs, and you can see that's actually what's happening here. So the clock goes high, my based off of what the data is, that's what's going to determine what the out is. So clock goes high, data is low, my Q goes low, which is correct, and my not Q does the opposite. That a 175 has 2 outputs, like one is the opposite of each other. It's like inverted. So yeah, and I'm just looking at one basically line. So it's a hex quadruple D type. The heck is hex? Is it 6 of them or 4 of them? Let me see. 1, 2, 3, 4. No, that's 4. I don't know what the hex means, I guess. 1, 2, 3, 4, 5, 6, 7, 8. Hex / quadruple. Is that because it's a 174 or versus a 175? I don't know, whatever. But this looks to be, doing the right thing, basically. It's just a typical, flip-flop. And if I stop it, I just found it interesting because I was messing with my channels. One of the things is I had to make sure all my probes were set up for 1x. So if you go to channel 1, then you go to channel 2, 1x, 1x. I was screwed up, and then I set them all to the same voltage. All of them are reading voltage level, volts per division of 5 volts. And everything's like basically a 5-volt signal, so, or 0 to 5 volts. All right. But yeah, so it looks fine. I mean, and the other thing is when the clock is low, it doesn't matter what the data is going to be. They're just going to maintain their state on the output. So even though there's, the data line's doing crap, when the clock is low or it's not rising, these are only being impacted when that clock goes high, as you can see. See? So now clock goes high, this is high, that goes high, that goes low. And this is a little bit more clear picture. So high, this is low, so that goes low, this goes high. So anyway, that's my best. Sean at Classic Arcade Repair is, he's got a logic analyzer. I don't have a logic analyzer, but I can hook up at least for these flip-flops. I can do something. I'll try to look at the counters too. I don't really know where the problem is, honestly. I'm just kind of hunting and pecking and trying to get a clue based off of what the theory of operation is saying, and I don't know how far I'm going to get. Learning how to use my oscilloscope, I'm just pressing the single, which I guess is a single trigger, I guess. I don't know. I have to research that if it just goes to the next clock trigger. But this one was interesting because my data outputs were already low and high, and the clock triggered and it was low, but Q was already low, so it didn't change. So there was no transition here, but that still looks normal. Whereas here, clock triggers, data in is high, this was low, so therefore it went high. This was high, therefore it went low. So anyway, I'm just looking at another LS175 on on the truth table. Here you can see the clear I already looked at. It's always high. It's tied high, I guess, but it looks like it's always high. I have to look at the schematic. So it's just pretty simple. If input is high, Q is high. If input is low, Q is low, and then not Q is the opposite, obviously. And then if the clock is low, regardless of what D is doing, steady state, I guess, is what that means. I don't know what 0 means, but that's what I'm seeing on the thing. So anyway, I'm doing some learning. It's kind of fun. All right, I'm looking at a different flip-flop, and really I'm just learning my oscilloscope. So I needed to change what I was triggering on because I wasn't really able to run a single sweep. I think that's what it is, a single sweep based off of the positive trigger. So I came here to menu, and then I changed my source to channel 3, which is one of the outputs, so I could trigger based off of the output changing and then correlate that to the clock. Because if I do the clock, oh whoops, damn it. Hold on, where am I at? Okay, channel 3. If I did channel 1 and then I adjust my trigger, yeah, there's my trigger, okay, and then I run single. See how every time I run a single sweep of the clock, I'm not really seeing what's going on the data outputs because they're in a constant state, because the data line, just the way the inputs are working for this particular chip or the signal, like the data is always high. It's not changing that often, the behavior, so it's hard for me to see if like it's working or not. So like there, clock went high, this was low, but output was already low, so, and this was already high, so there was no transition. So no transition, no transition, no transition. So what I did is hit menu over here for my, this is my trigger stuff, right? Yeah. And then come to my source, change my source to number 3. And then it shows my trigger value down here. Now run single shot, boom. Now I'm able to see, based off of these transitions, what's the clock, is it lining up? So clock went high, this was low, went high, and the data input was high, etc. So now I can kind of see that it's working correctly. See, look, I'm running single, it's just waiting for it to transition again. How come I didn't get it to go low? Should be able to see a low transition, I would think. I wonder why I never see it go low. It obviously has to be going low at some point. Oh, because I'm triggering on the going high. Duh. Alright, so let me change that menu, and we'll trigger on the, oh, I can't change it on the negative slope or something, or maybe that's on either, going up or down. Alright, let's try it. I don't know. That doesn't seem to be what I want. Triggering on the going down side. I guess so. Yeah, let me try that. Alright, now now it's going down. So clock went up. So, and data is low, so therefore my output went low. The corresponding inversion went up. So yeah, all right, whatever. Nice little Rigol stuff there, but honestly I don't know how much longer I'm going to keep working on this in this video. Well, everybody, I think I'm going to wrap up this video. Card's almost full anyway. Figured out 2 pattern boards. One was the reset line. I need to put a 161 at U5. I'm going to do a video on testing 161s and stuff in next video probably. And then I'm waiting on a 4516 up down, I think counters what it is. I can't remember. 4516, whatever it is. So waiting on that to fix this one that was shorted, had a pin that was shorted, and this one which had the reset line was messed up. So both of those are fixed. And I also cleaned this cage. I did it off camera. I cleaned this cage, and I did test the CPU board, but in my next video when I come back for these GORF boards, I will clean it and demonstrate it, because it is a little flaky, but I cleaned the whole cage. I'm not going to show that. I'll link to a video where I clean cages and stuff like that and fix the ground rails and stuff like that. But alright, that's it. This one's going to be a pain. We'll see how I fix it. Not sure. Cheers.